Okay, so what we're going to look at here is flows in OpenNMS and kind of how that works. Um, so let's go ahead and find a node that has some flows. We have a minion at the office right now in Ottawa that's actually collecting flows on all the traffic that goes through. So here's the actual node for the minion. We're going to go look at the resource graphs for a particular interface. And here we are. Last day, we see there's not much traffic, 10 kilobits right now. It's probably just overhead from sending the flows themselves back to OpenNMS. But what's interesting is this new little tool here, right, that shows up here, Open Flow Graphs. So basically the way that works is if we find that we do in fact have flow data for that interface on that node in the time period that you're looking at, then that little icon will show up. There's some little bits that you need to do to set that up, but that's basically the logic there. So if we do have some flow data, show this little icon. So if we click on that icon, what we do is it hops us over to Grafana. Of course, the URL there and the variables that are set on the dashboard are configurable. But what it done is pass the context of the node, the interface, and the time range that we had over. So we're now looking at the same time range that we were there and the same resource. So just quickly, if we extend that second row, what we're doing is looking at the SNMP data. So essentially the same graph that we have over here, right? Up top here, what we have is actually that same traffic, but determined by flows. So it allows us to break down that ingress and egress traffic and look at it in terms of applications. So in this particular appliance, we're using softflowd to capture the flows, which depends on libpcap. So it doesn't distinguish from ingress or egress in terms of flows. So everything, it just kind of bundles them all up in the ingress bucket. So which is why we don't have traffic split between in and out. However, router platforms do support that. So that said, what we see up here is just a combination of all the protocols that we've identified in that traffic based on the flows that were generated, right? So that allows you to see, okay, what's actually being sent over the wire there. So this SDP, some of the traffic's unknown. We have OpenVPN traffic, communication back with OpenNMS via HTTPS, SSH, DNS, HTTP, so on. So this is just showing the top N applications. I think N is set to 10 here. And if we go edit the graph, we see what that kind of query looks like. So for this, we've added a new data source to Helm that allows you to query the flow traffic. So right now we're saying, okay, fetch me the applications. I want the top N, include other. So what that does is it basically, anything that falls outside of the top N gets added to this other bucket. That way, the traffic that we see there represents the all the flows. And then we have some filters. I only want to show flows attached to this node, this interface, and convert the rates to per second. If we click plus here, there's some other like transforms and filters that you can apply to help change that criteria. So that's that panel. So the panel on the right here is basically similar to the view on the left, except instead of showing a time series view, it sums up all of the traffic. So it shows the total bytes transferred per protocol for that time period. Okay. So we can collapse this other row. We have this other row at the bottom here as well that tracks conversations. So again, in this time period, show me the top 10 talkers. Right, what were the biggest conversations? So that allows you to go a little deeper and say, okay, well, I know that HTTPS was the bulk of my traffic during this time period. Where was that going? So this will show the top N conversations. And they'll be grouped at the bottom there. Again, time series view of those, and then tabular view. So I see that the most bytes transferred were from 192.168.0.1 to this host here, SSDP, destination port 1900. Right. Next one is OpenVPN traffic, and so on. So that's pretty neat. So basically, this allows you to go from a high-level view of traffic, follow it through Grafana, break it down in terms of applications, and then take a deeper dive and identify the hosts that are actually consuming that bandwidth. Right. Question? Yes.
Yes. These panels are plugins we wrote, or is just reusing some panels from Grafana?
Yeah, good question. So the question is, are these panels, or what we're seeing here, plugins, or are they built into Grafana? So all the panels and visualization that we see here are built into Grafana. The only plugin we have is the data source. So if we look at the data source configuration here, I think I have probably a bunch here. Let's see, minion dev flow, right? So we have a new data source of type OpenNMS flow. And that allows you to query the flow data and shows the editor that we just looked at earlier. So same options as the other ones. Basically point it to your OpenNMS instance, give it valid credentials, and that's about it. And this client here actually uses OpenNMS.js to query the data. So anything you see here is implemented in OpenNMS.js there as well.
What security role do you need in OpenNMS?
For this, you just need a user role to query the flow data. Yeah, you would not need admin like I use here, just for convenience, really. Yeah, so that's just flows in a nutshell. How to get it all working? Let's kind of look into server configuration here. So if I go there. Telemetry deconfig that we looked at earlier. So we have the NetFlow 5 protocol enabled. So that gets so telemetry D is then able to process those flows. So these are actually being sent by a minion in this case.
Telemetry D is on the minion.
Minion is sending flows that gets processed by telemetry D locally in OpenNMS, right? And OpenNMS will then in turn send those out to Elasticsearch for persistence. Flows, features, flows, persistent, elastic. So a few settings there with respect to timeout, but it's using a Elasticsearch server that's just hosted on the same box here. The volume on the system is particularly small, so I'm able to just to host it all on the same instance. We can actually go maybe into Cabana and see what that looks like there. So okay, so here's the NetFlow indices in Elasticsearch. Also have this little plugin here that will kind of show us over time. So let's see. So I've been collecting data for quite a while now. And let's see, we're in September. So here's the index that we're currently querying, NetFlow 2018-09. So it's at 1.8 gigabytes. Last month, 1.5. The month before that, 24 gigs. So significant drop in NetFlow traffic. I think I may have disabled a few devices that were sending flows before. Either way, here's the Cabana, and we can look at kind of one of the documents, what they look like, one of these flows. And then it has all the, so basically we take SFlow, NetFlow 5, NetFlow 9, IPFix, and canonicalize it to this flow document that gets persisted in Elasticsearch. So all of them have these same fields and is extensible so that they can they could add more if necessary. So you see all the things that prefix with NetFlow is data from the NetFlow protocol. We have a version which identifies the actual source. So this one here is from SFlow. We also have some additional data related to that we add metadata to the flows that kind of contextualize it. So we see the exporter information. So where did this flow come from? It's telling us it came from node ID 1 or foreign ID and foreign source this. It also includes all the categories that were associated with that node. And also tags it with the source and target destination. So if it recognizes the IP addresses or the source or destination address in the flow, it'll include that same information and add it there. So you can see, show all me the traffic related to nodes in this category or something like that, right? So all those are stored there as records in Elasticsearch. And what happens whenever we go ahead and query the data is it sends a request to OpenNMS via the REST API, which in turn queries Elasticsearch and all the and then which aggregates all the flow records and builds time series from those and whatever based on what we query. All the aggregation for those records is done server side within the Elasticsearch cluster. So while developing that, we found that Elasticsearch didn't natively have the aggregation features that that we needed to render accurate time series data like this from the flow records. So what we went and did is actually developed a plugin called the OpenNMS Drift plugin, I believe. Let's see, Drift. Yeah, Elasticsearch Drift plugin. So this one here, it kind of explains the use case and what we're trying to do and what we couldn't do with the built-in aggregations in Elasticsearch. And we require that plugin to be installed on the Elasticsearch cluster in order for it to, in order for these queries to function. So that means that it has to be installed on all the data and coordinator nodes on the Elasticsearch cluster. Essentially, every system needs to have that jar available or installed. One thing that kind of sucks about the plugin API in Elasticsearch is that the plugins have to identify with a very specific build version, right? So that the plugin says, okay, I was built for Elasticsearch version 6.2.4. Then if you go ahead and upgrade to 6.2.5, the plugin won't work anymore. So we essentially have to make a new release or new package for every different Elasticsearch version. So right now we have a single one that supports Elasticsearch 6.2.4. I think that may have been the last one in the 6.2 series. But every time a new Elasticsearch, if you want to use the plugin with a different Elasticsearch version, we have to recompile and rebuild the packages for the plugin. One thing we've done is provide RPM packages that pin the specific version of Elasticsearch that we need. So if you depend on the packages, then you won't mistakenly update to an Elasticsearch version that's not supported. But yeah, that plugin does the brunt of the work of aggregating the data and doing that efficiently in Elasticsearch.
I guess there's no chance, given that contributed to Elasticsearch, we don't have to do that.
Yeah, so I kind of looked at it a bit, and we'd have to work closely with them to figure out a way to make that happen. I think make it more generic. I think there'd be some significant rework, and just haven't had the cycles to go through with that. But it is something that probably warrant being put upstream. Just have to change the way we do it now to fit their model and not just our specific use case. So yeah, that's kind of it. So flows come in, get processed by telemetry D. They go into Elasticsearch. We have a REST API that allows you to send in queries, process the data, expose it out, and then we have a plugin for Grafana that allows you to easily pull the data out and render it as either time series or tabular views, right? So that's the sampling interval. Oh, how many flows per second are we getting here?
Maybe not that, how often does it decide to send a flow record?
So I think this they'll have to look at that. So that would be determined by the soft load D process, the one exporting the flows. And I think the default timeout's like a minute or so. So let's say there's a TCP session. If it doesn't see any traffic related to the session for a minute, it'll flush it out and send the flow, something like that.
So if you zoomed in, your mid-2 data might drop off.
Oh yeah, that is a really cool thing too, that warrants looking at a little closer. So now we're looking at the last 24 hours for that same, or different interface, but on that same router that we're looking at before. So with SNMP data, what you have is we have 5-minute polling intervals, right? So if I zoom into, let's say, this section here, that's 2 hours. So you see that there's only a data point. You can see the point dropping every 5 minutes or so, right? So let's go ahead and zoom into a smaller section there, maybe 10 minutes. Right, so there's no, the window's too small to generate time series data from the IRD graphs. But if we see here on the top, the flows are fine enough so that we still have data covering that interval. And if you look at the level of detail there, we can even go in a little further. So let's go check out this peak here. So here we're covering from 35:52 to 36:54. So just barely over a minute, and see there's still detail. So let's go and see what happened right over here. So now we're looking at 4 seconds, and then we see, okay, wait, there was a peak right there, right? So let's go and see what. Unfortunately, you can't go less than a second, so gotta make sure it covers that. But yeah, it's pretty neat that we're now looking at a second or 2 second view, and we see at that point in time there was this traffic. So let's look at what hosts were actually most active in that period. Yeah, so there we go. So it's pretty neat. So you can go, the granularity of it is really neat. So you can go down to like the second.
So if you click on the legend, it filters out.
Yeah, if you click on one of these, it filters out that particular one. If you click again, it goes to all of them. So that's pretty cool. One thing, yeah, that I liked about that, and this is exactly why we need that that plugin that we've added to Elasticsearch. It can do time series aggregation. It just won't be as fine-grained or as accurate as you can see here. Anything else I missed? Any questions? How it works, or looks amazing. Marcus? Oh, okay, yeah, so Mark is bringing up Sentinel. So as we mentioned before, all the flows get processed by telemetry D. So that's something that lives in OpenNMS today. And for large deployments, that can become a bottleneck, right? So basically all these flows, this nice distributed processing, all goes to OpenNMS to process those and get those in Elasticsearch, which is, again, nicely distributed. So we realized that that was a bottleneck, and also if you're processing high volumes of flows, using a lot of cycles, that takes away from the job of the NMS of, checking services, handling traps, and, doing everything else it's supposed to do. So what we've been doing in 23 is developing another component called Sentinel that will allow us to essentially scale that processing. So Sentinel is a new container, new process you set up. And everything you can load on there can be ran in parallel or in a distributed fashion. So the idea is you can start one or many Sentinels, turn off telemetry D in OpenNMS, and then let the Sentinels do the processing. And then you can scale that up and down elastically as you need to be able to keep up with the load, right? So that will allow you to scale to process as many flows as you need, right? And so, yeah, initially we did support for flows, and just like I mentioned earlier, as we did recently, we also support the streaming telemetry and getting that into newts, so all that can, reach whatever numbers you need it to. So that was one thing, and another thing is the actual applications, right? So the control of determining how things get classified is there's actually a whole classification engine and UI there to be able to do that and can control how that gets done. So we can look at that quickly here. So configure OpenNMS. Yeah, manage flow classification. So here we are. We have a number of predefined rules. So these are from the IANA ports. So basically, there's a bunch of like standard names and protocols for known ports, right? Like, we know 80 is HTTP, HTTPS 443, Postgres, MySQL, so on. Use standard known ports, and all those are registered with IANA. So we have that data loaded as a standard definitions here, and that's the predefined rules category. You can also have user-defined rules. So that's where we got the NMS HTTPS one. My particular system is there. So any traffic with source or destination port, it's 443 gets classified as NMS HTTPS. So you can actually add your own rules. So the rules can filter source IP, source port, dest IP, dest port, particular IP protocol, and even only be applied to a particular set of exporters. So if you have, again, overlapping IPs and different things, you can say, okay, only apply these classifications if they come from this particular router, right? Or routers in this category, or things like that. So very flexible. And I think one thing is you can, turn these groups of rules on or off. So we have the user-defined rules or predefined rules. If you don't like the predefined rules we have, well, you just turn them off, and then you do your own, right? If you want to turn those back on, you can do it like that. There's also a handy little tool here that allows you to test the classification. So, okay, we have all these rules, now what? So let's say I were to have, let's say IPv4, just TCP, 192.168.1.1. So the flows are coming from this exporter, and it's saying that, this host on port blah is talking to that host on port, 3306. What would that classify as? That would classify as MySQL if it were to see a flow with that information. So pretty handy to verify what rules you have. And there's even a little more flags here. You can download the rule set as a CSV file, right? Open those up, edit them, and then upload them right back here, right? If you want to make those modifications a little easier, do them in bulk. Anything else? Did I miss? That covers it. So yeah, that's the classification. That's how you can define or control those applications. So pretty flexible. And I think I've covered all the bits. All right, well, thanks for listening.